So consider C of s divided by R of s is equal to omega n square divided by s square plus 2 damping factor omega n s plus omega n square. This is the standard form of second order system. So here you can see I can calculate the dynamic behavior of the second order system in terms of two parameters, that is the damping factor and the omega n. For underdamped case, the damping factor value must be in the range of greater than 0 and less than 1. So if it is equal to 1, it is called as critical damping, and if it is equal to, or if it is less than 1 means it is undamped, and if it is greater than 1 means it is underdamped, overdamped. So here in the underdamped case, the poles are complex conjugate and it is lies in the left half of the S plane. So I can write this C of S divided by R of S is equal to omega n square divided by this S square plus the denominator term I can write it as S plus damping factor into omega n plus J into omega d into S plus damping factor omega n minus j omega d, where this omega d is called as the damped natural frequency, and its value is equal to omega n root of 1 minus damping factor square. So if R of s is equal to 1 by n, so here my input is unit step signal. I can write C of s is equal to 1 divided by s into omega n square divided by s square plus 2 damping factor omega n s plus omega n square. So I can write this one as is equal to a divided by s plus bs plus c divided by s square plus 2 omega n s damping factor plus omega n square. So here a I'm going to multiply with by taking LCM, s square plus 2 into omega n s damping factor plus omega n square plus bsc plus c into s is equal to 1. Okay, sorry, that is equal to omega n square. Since you can see in the CFS I have omega n. Now I am going to equate the s square term. So I can multiply a with s square, right? So a plus b is equal to 0. So is in the right. So next I am going to equate the s term. So if I equate s term, so before that I can write a is equal to minus b. So 2 into damping factor into omega n a plus c is equal to 0, right? Next what I am going to do, I am going to substitute my s value is equal to 0. So if I substitute s value equal to 0 in the first equation, I will get omega n square a is equal to omega n square, therefore a is equal to 1. So I substitute in that equation, so a is equal to minus b, so b is equal to minus 1. So once I get the a and b value, I am going to substitute in this equation, so I will get c is equal to 2 minus 2 omega n into damping factor, right? So what is my C of s? C of s is equal to 1 divided by s, since a value is 1 and b value is minus, so minus s plus so since c value is minus, so minus 2 omega n damping factor divided by s square plus omega n square plus 2 omega n s damping factor. So thus I can rewrite it like this, right? So you can see this 2 into omega n into damping factor, I can write it as 1 divided by s minus s plus damping factor into omega n divided by the denominator value minus, right, minus damping factor into omega n divided by the denominator value. Transform. I'm doing like this. Okay. So this denominator value, I can change it as s plus omega n into damping factor the whole square plus omega d the whole square. So why I am writing like this means this omega d is nothing but omega n into root of 1 minus damping factor square, right? So if I take a square term, it will be this. So I'm going to substitute it here. Okay. So if I equate this term, I will get the above denominator value. So you can see this is in terms of a plus b the whole square, right? So you apply that formula. So once you apply that formula, you will get this one plus omega n square minus omega n square damping factor square. So these two get cancelled out. So you will get the denominator value, right? So I can write like this minus damping factor into omega n divided by s plus damping factor omega n the whole square plus omega d the whole square. So now I can take the inverse Laplace transform. So if I take inverse Laplace transform, my c of t is equal to 1 minus e power minus damping factor into omega n t, because s plus term you have. So okay, s plus is with damping factor into omega n and cos omega d t minus, here I am going to multiply this with omega d on both sides. So if I multiply with omega d on the both side, I will get e power minus damping factor into omega n t um, into damping factor into omega n divided by omega d into sine omega d t. Here you can see if I take e power minus damping factor into omega n t common, I will get cos omega dt plus damping factor into omega n divided by omega n into root of 1 minus damping factor square sine omega dt. So this omega n and omega n get cancelled out. So I can write the equation like this. If I plot the graph for t versus c of t, okay. So for underdamped case, it will be like this. Okay. So this is my 1, and at t, so at when it will reach the 1, that is a time taken. This time is called as tr, and the maximum value after reaching the 1, the first maximum value it reaches is mp, that is maximum peak overshoot. And since it is you can see this blue value is nothing but a tolerance. So the tolerance value is 0.05, that is 5% and 2%. So this is a allowable tolerance value. Next TS. So TS is nothing but a settling time. So generally it is 98% of the final value, right? Next one is delay time. So it is a 50% of the final value of the C of t. So it is represented in terms of TD, that is delay time. Next, the time it take to reach the first peak or peak values, peak time, that is TP. So it is the time required for the response to reach the first peak of the overshoot. So now I can write the C of t value. Okay, so first let us find the rise time. So the rise time is the C of t r reaches the value at t is equal to tr. C of tr reaches 1. So you substitute the value of 1 here. So the 1 and 1 get cancelled out. So this whole term get equate to 0. So now what we are going to do is since the poles are complex conjugate and it should have lie in the left half of the S plane, you can see the S can equate to 0. The S is equal to minus of damping factor into omega n minus j omega d plus j omega d. So the pole will be here, and you can see this is a damping factor into omega n, and this is theta. I can take as soon as theta, and the vertical axis is omega t, right? So let me copy it here, and I'm going to substitute in the this equation. So if you see, I can equate sin theta. Sin theta is equal to opposite side, that is omega d divided by the hypotenuse value, that is root of omega d square plus damping factor to omega n the whole square. So we know that omega d is equal to omega into root of 1 minus damping factor square. So I'm going to substitute the same here. And if we equate this one, you can see this omega n square and damping factor square that cancelled out. So you will get root of omega n square, right? So what is root of omega n square? That is omega n. So you will get 1 minus damping factor square, right? Root of 1 minus damping factor square, that is your sin theta. In similar way, I can write cos theta. That is equal to damping factor omega n divided by this hypotenuse value. That is nothing but omega n, right? So I will tell you how we have derived in the previous equation. So you will get cos theta is equal to damping factor. So you substitute in the above equation. So if you substitute, you will get t power minus damping factor omega d t. Okay, the t is tr, right? Divided by 1 root of 1 minus damping factor square. So this I can write it as sin theta. Sin theta cos omega dt plus cos theta sin omega dt. dt, right? So that must be equal to 0. So if I equate this one to 0, what I will get, this I can write it as sine of omega, since e power minus term goes to 0, I can write this term as equal to 0, right? So according to sine a plus b, the form a plus b form sine, here a is omega dt plus b is d is nothing but b is nothing but a is theta and down b is omega dt. So you will get sine inverse of 0. Sine inverse of 0 I can write it as n pi, right? Here t is equal to tr, right? So I can write this tr value, right? Tr value is equal to m pi minus theta divided by omega t. Like here I can substitute this n value is equal to 1. Okay. So what is tan theta? Tan theta is equal to omega d divided by damping factor into omega n. We know that theta is equal to tan inverse of omega d divided by damping factor into omega n. So if you want, you can substitute the value of omega t. So if you substitute the value of omega t, you will get this answer. This is your theta. Okay. So if you want, you can substitute this equation. Okay, what is theta? So this rise time must be measured in terms of seconds. Next, we will discuss how to find the value of peak time. Okay, so you have to equate this output response, differentiate this output response to 0 in order to get the values, right? So here, so for that one, let me copy the value of CT. This is my value of CT, and I am going to differentiate this one with respect to t. So you will get 1. If I differentiate with respect to t, it goes to 0. So minus e power damping factor omega n t. So if I differentiate cos omega dt, I will get minus sin omega dt into omega t plus damping factor divided by root of 1 minus damping factor square. The sin omega dt, if I differentiate, I will get cos omega dt into omega dt. So it is in terms of UV formula. So therefore, again, I am going to have minus e power j omega n t damping factor. Okay. Now I can write minus cos omega d omega dt plus damping factor divided by root of 1 minus omega square sin omega dt, and if I integrate e power minus damping factor omega nt, I'll get minus of damping factor into omega n, that is equal to 0. We have to substitute t is equal to T3, right? So if you see, if I equate the sum, I will get this cos and cos term get cancelled out. So if the cos and cos term get cancelled out, I will get the answer as minus of this minus and minus get cancelled out. So you'll get e power minus damping factor into omega n t p sin omega dt omega d plus damping factor square divided by root of 1 minus damping factor square omega n sin omega dt into e power minus damping factor omega n tp, that is equal to 0. So I can write here my sin omega d tp is equal to 0. So omega d tp is equal to sin inverse of 0. So sin inverse of 0 I can write as n pi. So t pi is equal to n pi divided by omega t. And if I substitute n is equal to 1 and 2, 3 and 5, I will get dp is equal to pi divided by omega d for n is equal to pi. Next one is to find the maximum output. So mp, that is equal to c of tp minus 1. So how to find the c of tp? So just copy and paste the value of c of t, and I'm going to substitute t is equal to tp. So like t is equal to t TP value is pi divided by omega d. So I'll just substituting that value of TP in all the equation, and I'm going to cancel this sin pi terms because sin pi is 0 and omega d and omega d get cancelled out. So what is cos pi? Cos pi is so minus 1. So I'll get MP is equal to C of TP minus 1. So this 1 and 1 get cancelled out. So we'll get MP is equal to minus of e power minus damping factor omega n pi divided by omega n root of 1 minus damping factor square. So since cos pi is minus 1, I'll get MP is equal to e power minus damping factor pi divided by 1 by root of 1 minus damping factor squared. So usually it is measured in terms of percentage. So it is I'm going to multiply 100 percentage. Generally MP is equal to C of TP minus C of infinity divided by C of infinity. So C of infinity get calculated when if it is not going to infinity. It is the output response is not unity. Next, to find settling time. So here I'm going to substitute t is equal to t of s at in the C of s equation, C of t equation. So if I substitute and we can see during the settling time the output should not get oscillated. So therefore the cos and sin omega bt term they cancelled out. It goes to 1. So I'm going to get C of ts is equal to 1 minus e power minus omega n ts into damp effect, right? So I'm going to equate the term into 0.98. So C of ts is equal to 0.98. So 1 minus 0.98 that is nothing but 0.02, right? So if I take ln of 0.02, that is equal to minus omega n damping factor into ts. So ts is equal to 1 divided by damping factor into omega n ln 1 divided by 0.02. So that is equal to 4. So TFS is equal to 4 divided by damping factor into omega n. This is for 2% tolerance. It is 0.02. So if it is for 5% tolerance, so TFS is equal to 1 divided by damping factor into omega n ln 1 divided by 0.05. That is equal to 3 divided by damping factor into omega n. That is usually measured in terms of seconds. So what is E of t? E of t is equal to limit t tends to infinity R of t minus C of t. So here the 1 minus 1 is since R of t is unit step signal, 1 minus 1 1 minus 1 minus e power minus that C of t value. So this 1 and 1 get cancelled out. So you'll get and if I substitute t is equal to infinity, e power minus infinity is 0. So e of t is equal to 0 as t tends to infinity, right? So here for underdamped system, the steady state error is